Hello, my fellow mathematician. Welcome to this study whereby we are looking at exact difference equation. So we can label this equation 1. We are going to solve this equation. So the first thing which we do, it is we find our m, which is m will be equal to m is a function of x and y, which is the function where dx is, and in this case it is 2xy, you call this equation 1. Then you let your n, which is equal to a function of x and y, and it is the function where and dy is, in this case it is x squared plus cos y. So you call this, so this is equation 2, this other one you call it equation 3. Then the next thing which you do, you test for whether this equation is difference equation is exact by finding partial derivative of m with respect to y. So when you differentiate equation 2 with respect to y, the result will be 2x. Then the next thing, you also get partial derivative of equation 3 with respect to x, which will give you 2x. Now, in case now your result, if your dm, partial derivative of dm over dy is equal to dn over dx, in our case it is equal to 2x. So since these two ones are equal, it means our difference equation is exact. So if now, because our equation is exact, this is what we are going to do. We are going to employ the following formula. The result which we seek, our answer will be of the form f of xy is equal to c, where c is constant, and our equation is of the form m dx plus n dy is equal to 0. From what we are given df of dx, from equation 1 which we are given here, this one, it is 2xy. So that is what we are going to employ down here, 2xy. Then the next thing, what you do now, you can call this, what you do here, you integrate this equation. So you have df, which is equal to 2xy dx. You integrate both signs. When you integrate this equation, we are going to get f of xy is equal to, this will give you x squared y plus a function of y that way. So you can call this equation 4. We call that equation 4. Then from equation 4, we get df of dy, which will give us x squared plus function of y differentiated. Then the next thing which you do now, you can call this equation 5. We are going to compare our equation 5 with equation 3. Equation 3 is here. Our equation 3 is this one. So we are going to compare equation 5 with equation 3 to obtain the following result. df over dy is equal to x squared plus cos of y. I have written equation 3 here. So when you compare equation 5 with equation 3, you can see the left side, we have df over dy. They are equal. So we are going to equate the right hand side to get the following. So here we are going to write this x squared plus cos of y is equal to x squared plus gene differentiated of y. You can see x squared will cancel because it is on the left hand side and on the right hand side, so that we will be left with g of y is equal to cos of y. Then from there, you integrate both sides of this equation. When you integrate and you are differentiating, you will be left with your function. So g of y is equal to, when you integrate cos of y, the result will be, here you can even write, the result will be sine of y plus constant c, whereby c is the constant of integration. You call this equation 6. Then you substitute equation 6 in equation 4. Equation 4 is here. We substitute equation 6 in equation 4 to obtain the following. So our result will be f of xy is equal to x squared plus sine of y plus constant c plus constant c, sorry. So that is our result of the given equation. That is the result of the given equation. There is y here which I had forgotten, sorry. So f of xy is equal to x squared y plus plus sine y plus c. So thanks so much for taking your time to study with me on how to get the solution of an exact difference equation. For more examples on exact difference equation, stay tuned in my YouTube channel. Also, if you have not subscribed to this channel, I request you to do so that you don't miss a single video which I upload for us every day. Thanks for your support. You can also share with the other mathematicians so that we may continue learning together. Bye bye. See you in the next presentation.